So I'm going to take a stab here at explaining how to set up the model in Excel. Now I'm using Apple Numbers, which is their equivalent. It's going to be exactly the same thing in terms of setting up a spreadsheet. Now one of the nice things about a spreadsheet is it gives you columns. The idea would be, and this is not how, you can do a bunch of other things with Excel, but the main thing you probably want to do anytime you're dealing with a database is to have each column give you one piece of information and one piece of information only. So here I'm going to set this up for this to be capital, this to be output, this to be investment, and this to be depreciation. Now I'm going to go ahead and put in 0.1, 0.5, our parameters up here. This would be our alpha. Our investment rate according to the book is 30%, and our depreciation rate according to the book, again, in the way that they've set this up, is 2%. Now we can go back and play with this some more. Now I'm just going to seed some values in here, and this is going to be the exciting bit. Because remember, our Solow model gives us the ability to look up if our level of capital is, something else, and so on and so forth. So let me see if I can just copy and paste way the heck down. Let me see, equals, oops, I'm just going to set this up to equal this plus 1. So you can set up formulas here. Oh, come on. And so you can set up relationships. So I'm just going to create a whole bunch of space down here, which is, actually, let's see here. See if there's an easy way. Now you can just copy, since that's a formula, you can copy it down and it will automatically fill. Let's, oops. No. Yeah, and now it's automatically, the program has figured out what I'm doing, and yay, it's now we're just gonna pull this out way, at least past 225. I'm gonna probably go ahead and pull it out to at least 500 here so that we have some room to play with it. And yes, there might be quicker and easier ways to do this. What I should have done, what I should have done and what I might still do is, but wow, this is fine. You can see, we'll see how long this actually takes doing this the long way. Because my suspicion is it still will not take very long. But actually, let's just do this. I can now take this, copy it. Nope. I guess that does not work. I think actually maybe I can highlight larger portions and then copy down. Turns out for any of you who have worked with Excel, there are a whole bunch of other tricks that you can do. There we go, yep. So that's one to make this quicker. So now we're out past 500, okay. All right, and so now we can set this up to equal this to this power here. Now I'm going to want to set this, the dollar signs allow me to preserve the row and the column. In other words, every formula is going to refer to this as the exponent. So 1 to the first power is 1, and now the fun begins. I copy this all the way out till we get to the bottom. I'm just going to, there we go. And then investment is what? Well, investment is 30%, so I'm going to actually, again, set that to be the row and the column, just keep those the same. The dollar sign trick is awesome, times this value here. And so in other words, what that's going to do, I'll pull up this formula, is, pull up this formula, is that as you copy it down, it's going to keep C1, the constant frame of reference there. And it's going to then change B3. The next one will be B4, the next one will be B5, etc. Now why that's relevant, I'll show you in a minute, because if you set it up this way, you can change any of the parameters and see an immediate response in the underlying piece. Okay, so this here, did I set this? Yes, I did. I set this to be the right thing. So one of the common mistakes people make is they make investment a function of capital rather than investment a function of output. So I'm going to do the same thing here. I'm going to say depreciation equals capital. times 0.02. So I'm going to preserve the row and column here, and I'm going to not preserve the row and column here. And so now this equals this times this. And now if we copy this down, and I'll go back and show you that it has in effect copied. Let's double check and make sure that this bottom one here, so let's make sure this one, yeah, so with the $ trick, what that has now done is keep D1, our constant frame of reference here, and has changed the capital value. Okay, so what the heck do we do with this? Well, let's see if I can now graph these. We're going to leave capital off and hope that my program figures out. So now I'm going to go to a line graph. And yes, now I'm going to go in and I'm going to format these. Chart options, legend, we can take some of these off. Yep. Let's look at the show minimum value, series, data symbols. There we go. That's a little easier to see. Now I'm going to remove these columns because we're not going to need them for this example. We can then move this over. We can increase this. Okay. So now what happens? Say that now you want to play with this and you say, okay, let's set our depreciation rate. Instead of it being 20%, now let's set it equal to 10, or sorry, it was at 0.02. There we go. So that's where it was. So in other words, nothing moved there. Now let's change it to 1% instead. And you'll notice that our line immediately moves to the point where it's not even going to cross our investment line within the 500 range. On the other hand, say I increased it to 10%. Whoa, there we go. So this is one of the things you can use if you've got this set up. You can double check yourself by seeing if you can set this up. And then you can play with the underlying parameters. So let's say we go back to 0.02. And now maybe I'll get rid of the formatting here, and maybe you say, well, you know what? Let's see what happens, like in the example we looked at, when the savings rate goes down and that we have a lower savings and investment rate. Oh, cool. That line just shifted down. And maybe we could look at, we can go now up, reset that to 30%, and maybe now we say, well, what happens if instead of this being 1/2, this is 1/3? And I'm going to have to play with that because this is going to need to be an equals 1/3. There we go, right? Or we could say, what if it was 0.25? And you'll notice that as we change this, our investment line is moving despite the fact that our investment rate hasn't changed. And the reason for that is because investment is a percentage of output, and so if our output line shifts, our investment line must shift. However, it is entirely possible to have our investment line shift without our output line shifting. So I'll reset this to 1/2. So there you go. You can set this up. You can play with it. Now I'm going to do one other thing here, and I'm going to actually now put in time. So we have year here, and let me get rid of this column. And here we have capital, and here we have output, here we have depreciation. Oh, I'll go back, and here we have investment, and here we have depreciation. And I'm going to create another line up above. Here, this is 1/2. I'll go with the book's parameters, but you can then go in and change them. Again, I can set this up to change however we want it to change, or set it up and then change it however we want to change it. Okay. So there we've got our starting parameters. And so now, I'm just going to oh. And we can, oh, nope. Copying the formula all the way down, and then hopefully, oh yeah, we can go out hundreds and hundreds of years here. Oh, let's do this. And yes, I'm sure watching me actually do this is kind of like watching paint dry, which is why I have generally resisted doing this unless somebody comes into my office hours. But so here we go. We're out to, yeah, over a millennia, right? So here, I'm just going to start us with a seed value of 1 because we have to have something to begin with. And then this is going to equal that times, oops, no, that to this power. All right, fairly straightforward. And this again equals this times this. I'm going to have to actually preserve the row and column. Again, for any of you who are doing this manually, you just put a $sign before the letter and a $sign before the number. One of them locks in the column and one of them locks in the row. I can never remember which, so I usually just put both of them there. Yes, and so this equals our output times 30%. And I meant to lock that in. There we go. And here, this is our depreciation rate. Again, we'll keep that constant so that we can tweak it. We'll keep it constant in our formulas. In other words, referencing the same cell. And that is going to be that value times capital, right? The amount of 20%, or sorry, 2% of the machines that we have will simply break down. So the trick here now is our next year's capital is going to equal our previous year's capital plus our investment minus our depreciation. And so there we go. We have 1.28 the next year. I'm just going to copy these formulas down. So you'll notice these still should refer to the same. Yep, so this is 2% times that. And then we can just copy all of these down. And it should nicely produce a result here. There we go. So now what do we do with this? Well, now what we can do is what I showed. Oh, and maybe I want to put in a separate. So now we'll do a percent change in Y column. And what that's going to be, we're going to leave that one blank, is going to be our new minus our old divided by our old, all of that times 100. And you might have some questions. This probably actually should be up 1 because that would be the growth rate within that year. So this would be new minus old divided by old, all of that times 100. And so and obviously that one's not going to work. So you're going to be missing one value, either the one at the top or the bottom, and that's kind of up to you. So, oops, we're missing some values. Let's see if why we're missing values. Maybe I started it part way. So you can actually copy up the other direction. Okay. And so now let me graph, let's try throwing in a graph of output across time. We go all the way down, and actually we could do both output and percent change in output on the same graph. We'll do that. We'll chart this. And I'll do the same thing, removing the dots because they tend to make that. And there we go. And so this is where those videos I showed you with GDP across time and growth. So it turns out that from our model, we can back out what will happen with time. So across the bottom here is time. And here is a numerical value. And so time is in here. Now this blue line looks a lot like our Solow growth line, but it's shaped similarly, but it is a fundamentally different line. It's dropping out of our model rather than being a foundational piece of our model. Now, if you play with this, this is what in effect I did with those pieces that I showed you. I said, what happens if we look at this when we increase the investment rate to 40%? There you go. And what happens if we increase the investment rate to 50%? There you go. And I could also change that as time goes by. Which is what I did. I could segment and I can change the formula once we get partway through. Same thing with depreciation. We can reset this to 30%, and maybe we now increase the depreciation rate to 12%. And boy, does our growth and our GDP, do they fall, right? Which shouldn't be too surprising. If a lot more machines break down, rather than generating new stuff, most of our activity is going to be spent collecting the old stuff. So we can reset this. This again would allow us to play with any of the parameters. And this hopefully helps you understand A, how to use Excel, and then B, how this works across time.